Rationalizing two-term denominators. Previously, we rationalized denominators where there was only a single term in the denominator. But when you have two terms in the denominator, things become a little bit trickier. So for example, just to see what one of these looks like, 5 over 2 minus the square root of 3, that has two terms in the denominator. And I want to show you what would happen if I multiplied by the square root of 3 over the square root of 3. What would happen? Well, I'd get 5 root 3 on top, and on the bottom, I'd have to multiply each term by the square root of 3. So it'd be 2 square root of 3, and then minus the square root of 3 times the square root of 3 is just 3. So I didn't get rid of the irrational number in the denominator. That technique that we were using before only works when there's one term in the denominator. But because I had to multiply it by both terms in this example, I still have an irrational denominator. So with two terms, to make a denominator rational, we have to multiply the top and bottom by the conjugate of the denominator. Now the conjugate of a plus b is a minus b, and the conjugate of a minus b is a plus b. So you will notice that what's different between, well, the conjugate of a binomial is just the binomial repeated, but with the sign switched in the middle. That's what's happening in each of these examples. Now, why we do this, I'm going to show you, but we actually sort of saw it earlier on when we were multiplying radicals together. When we multiplied a radical with this pattern, we saw the radical disappear in the final product. So there is a reason why we choose to multiply by the conjugate, and we're going to see that now. So to start, we're going to start this slowly. First, identify the conjugate of 3 minus root 5. Well, all we have to do is switch the sign between the two terms. So the conjugate is 3 plus root 5. Now we're asked to multiply 3 minus root 5 by the conjugate 3 plus root 5. And to do that, we'll have to FOIL. So first, 3 times 3 is 9, and then I have 3 root 5, and then I have minus 3 root 5, and finally negative root 5 times positive root 5 is just negative 5. And what do we see happen? Well, these two radical terms from the outside and inside of our FOIL, they cancel each other out, and I'm left with 9 minus 5, which is equal to 4. So what did you notice? We are left with a rational number. The roots canceled. So this is why we're trying to identify and then multiply by a conjugate. Because if we have a radical, a two-term radical in the denominator, just by multiplying by the conjugate, we're going to be able to get rid of it in the denominator. Okay, let's do this again. 3 root 2 plus 1. The conjugate is going to be 3 root 2 minus 1. All we have to do, reverse that sign in the middle. Now we're going to multiply 3 root 2 plus 1 by its conjugate, so that would be 3 root 2 minus 1. And just be careful as you're going through this. So 3 root 2 times 3 root 2 is 9 times 2. And 3 root 2 minus 1 would be negative 3 root 2. 1 times 3 root 2 is plus 3 root 2. And 1 times negative 1 is negative 1. And again, we see these radicals cancel. And we also see that the first terms in our FOIL right here, 3 times root 2 times 3 times root 2, those root 2 times root 2 is equal to 2. So our radical also disappeared there. So this would be 9 times 2 is 18 minus 1 is 17. What did you notice? Radical gone. So this is the power of the conjugate. And now we're going to put this knowledge of conjugates into action. We're going to get rid of this denominator by multiplying top and bottom by the conjugate of the radical in the denominator. So the conjugate of 2 minus root 3 is 2 plus root 3. So we multiply top and bottom. Now be careful in these steps. On the bottom we have 2 terms, so let's FOIL those. And on the top we have 5 times 2 plus root 3. So we have to multiply 5 by each of those terms in the conjugate there. So 5 times 2 is 10 in the numerator. 5 times root 3 is just 5 root 3 in the numerator. In the denominator, just go ahead and FOIL. Eventually you'll start to get confident and you'll be able to predict what the denominator is going to look like, but for now just FOIL and you'll make fewer mistakes. So 2 times 2 is 4. 2 times root 3 is 2 root 3. Negative root 3 times 2 is negative 2 root 3. And then negative root 3 times root 3 is negative 3. And when you FOIL, you're going to see that cancellation happen. That's good. If you don't see it happen, it's because something went wrong and you should go back and check your work. But for now, we see that cancellation happen, so we're left with 10 plus 5 root 3 over 4 minus 3 is 1. And that's probably not the easiest, simplest way to write our answer, so let's just write it without that 1 in the denominator. And there's our final answer. So kind of interesting, rationalizing the denominator actually got rid of the denominator altogether. That won't happen in every case. Now here's an interesting example because we actually have a radical of a variable. But again, it just doesn't change the strategy. We just have to keep multiplying top and bottom by the conjugate. So root u, doesn't matter if it's a variable there, root u plus 2 root 6 and root u plus 2 root 6 on both top and bottom. And now we multiply away. So I'm going to be multiplying the top first. So that would be root 3 times root u is root 3u. And root 3 times 2 root 6 is 2, and then 3 times 6 is 18, root 18. That's going to be simplifiable, so I'll do that in a bit though. And then on the bottom, just go through the FOILing process. So root u times root u is u. And then last, root u times 2 root 6 is 2 root 6u. Inside terms, minus 2 root 6u. And last terms would be minus 4. That's negative 2 times positive 2. And root 6 times root 6 is just 6. So as I said in the numerator, I have 3 root u plus 2, and I can simplify root 18 by using 18 is 9 times 2. And in the bottom, I see that cancellation happen in those radical terms, and I'm left with just u minus 4 times 6, or u minus 24. So, it looks a little bit different, but it's a totally perfectly valid answer. So u minus 24 in the denominator, and in the top I have 3u plus, well, the square root of 9 is 3, so 2 times 3 is 6 root 2. So there's my rationalized, my fraction with a rationalized denominator.
Okay, so in this next example, we are going to be dividing root x plus root 7 by root x minus root 7. So this is actually a rational expression in disguise, because if we rewrite this, we actually have root x plus root 7 over root x minus root 7. Okay? And as we've seen before, we have this radical expression, this radical binomial in the denominator, so we need to rationalize it by multiplying by the conjugate. So the conjugate of root x minus root 7 is root x plus root 7, and whatever we multiply in the denominator, we have to multiply in the numerator as well, so that the value of the expression doesn't change. And this is just a coincidence, but you'll notice that the top two numerators are identical. Doesn't change anything in our process, but just a fun little side effect here. Okay, so when we are expanding the tops, right, we pretend each of these numerators are their own brackets. Ditto with these denominators. And if we FOIL through the two numerators, we get root x times root x is x. And then we get root x times root 7 is root 7x. And root 7 times root x is another root 7x. And root 7 times root 7 is 7. And then in the denominator, we have root x times root x is x. Root x times positive root 7 is plus root 7x. But now we have a negative root 7 times root x on the inside, so we minus root 7x. And then minus root 7 times a positive root 7 is minus 7. So as we can see in the denominator, we should expect this by now, but the two middle terms cancel. We have a positive root 7x canceling out a negative root 7x. So you can simplify this. Up top, we've got an x. And since we have one root 7x plus another root 7x, we actually have two root 7x's. And then we have our plus 7 still. And all of that is being divided by simply an x minus 7.